Welcome to episode 5 of the 3n+1 show. I'm Kevin Knight. To recap, the 3n+1 conjecture says, start with any number. If it's even, cut it in half. If it's odd, multiply it by 3 and add 1 and cut that in half. Then repeat. The famous 3n+1 conjecture asks, does every number go to 1? Okay, last time we found that 93% of all numbers go below themselves within just a few steps. So we want to see now if we can get this up to 99% or 100%. How far can we push it? So check out this amazing pattern. Here are the numbers from 1 to 15. Let's write down the initial sequences for each one. First we have 1 times 3 plus 1 over 2 is 2. Cut it in half, 1, and then 2. Now that's odd, even, which we're going to mark with yellow and blue. Okay, next is 2, 1, 2, 1, which is even, odd. Okay, and next is 3 times 3 plus 1 over 2 is 5, times 3 plus 1 over 2 is 8, and then 4, which is odd, even. So this odd, even sequence arises because we apply different operations as we go depending on what the start number was. So we'll call that the operation sequence. So let's keep going here. Okay, we've got 4, 5, 6, 7, 8, 9, skipping all the details. And then finally we have 15, which is, let's see, 3 times 3 plus 1, 46 over 2 is 23, which goes to 6, 7, 35, and then to 106, 53. So that's 4 odds. So we'll add 4 markers there. And then let's add back the number 0 just for completeness. 0, 0, 0, 0 is 4 evens. Okay, there's an amazing overall pattern here. Every number from 0 to 15 is associated with a unique odd-even sequence. So there's a one-to-one mapping between start numbers and their initial operation sequences. And this is going to help us figure out which numbers go below themselves. So remember in the last episode we found out if there's the same number of evens as odds, the sequence trends downward. So for example, if we start with 17 and first go up and then go down, we'll wind up with a lower number, 13. So actually, to stay above itself, a number needs at least 60% of its sequence to be odds. So imagine a big number like 76 million something. Its initial operation sequence is going to be something like this. Some sequence of odd and even. Now, unless there's at least 60% odds, that big number is going to wind up lower than itself after those operations are applied. Okay, so now we can imagine not just 15 numbers, but a huge set of numbers all the way up to, say, 2 to the 1000th. And we can imagine each number has its own distinct initial sequence of 1,000 operations. So how many of those sequences will cause the start number to stay above itself? This is like flipping a coin 1,000 times. In how many universes will you wind up with more than 600 heads? So I'd bet my life against $50 that it'll be less than 600 heads. The chance is actually 0.0000001%. So we can now say that 99.9999999% of all numbers under 2 to the 1000th wind up going below themselves after just 1,000 operations. And we're sure of that. We don't need to check them. And that's a lot better than what we had in the last episode, which was 93%. And even better, the more numbers we consider, the higher this percentage gets. So mathematicians like to say almost every number goes below itself. Almost every has a kind of technical meaning. It means the more numbers we consider, the closer to 100% of them have the property we're talking about. Now, if almost every number goes below itself, does that mean some numbers don't go below themselves? Nah, this is just how mathematicians talk. The other numbers probably go below themselves too, we just don't know. Okay, so we know almost every number goes below itself. Can we say something about how low those numbers go? For example, do almost all numbers go below 1% of their original value? Turns out, yes, that's been proven. And do almost all numbers go below some unimaginably small portion of their original value, such as log, log, log of the start number? Yes, also. This was proved by famous mathematician Terence Tao in 2019 in a 40-page paper. Now, do almost all numbers go to 1? That we don't know. But we've learned in this episode that almost every start number eventually winds up really, really small. So have we proved the 3n+1 conjecture? Not yet. So stay tuned for the next episode.